A 15-liter tank contains 16.26 grams of dioxygen. Calculate the pressure of the oxygen at 30 degrees Celsius. Is there a change? There's no change, is there? So we don't need to use the combined gas law. We can use the ideal gas law, which is simpler in one way. Certainly, it's more straightforward in setting the thing up. Less opportunities for making an error. However, you have to remember what we said a few minutes ago. The volume, the temperature, and the pressure have to be in the right units. So, as we look at this, we're given the volume in liters, the temperature in Celsius, that's going to have to be changed to kelvins. And the mass of oxygen, which is going to have to be changed to moles of oxygen. Okay? So the summary of the variables here, V is 15 liters, T is 30 degrees Celsius, we're going to have to change that to Kelvin, and the mass is 16.26 grams, we're going to have to change that to moles, but we're old hands, experienced people with regard to doing mass to mole conversions. So first of all, let's convert temperature from degrees Celsius to Kelvin. I hit the pen one too many times. We have 30 degrees Celsius, so come on, pen. We have 30 degrees Celsius plus 273 will be 303 kelvins. Okay, we're going to use PV is equal to nRT, and we're going to solve for P. So P is going to be nRT over V, and V is already in liters, that's good. T is now in Kelvin, so that's good. The only thing we have left to worry about is N here. N is not mass, it's moles, so we need to do mass to mole conversion next. Okay? So 6.26 grams of oxygen times the mass to mole conversion factor for O2, which is how oxygen comes, gives us 0.508 moles of O2. All right, so now we're ready to plug in. P is equal to nRT over V. Here are the numbers. 0.508 mole is N. Here, 0.0821 liter atmospheres per mole Kelvin. And notice I slipped it in there in the way I like to write it. Liter atmospheres per mole Kelvin, that's R. Here's T, 303 kelvins. Here's V in liters. And notice that moles cancel with moles. Liters cancel with liters. Kelvins cancel with kelvins. And that answer is in atmospheres. So the pressure in that tank is 0.842 atmospheres. If we needed it in torr, then we would just convert atmospheres to torr. We know how to do that.